Myself Pushkal Kumar Shukla, Assistant Professor in Computer Science Department at Ajay Garg Engineering College, Ghaziabad. Today I will discuss a concept of Pigeonhole Principle, which is important topic in Discrete Mathematics and useful for the B.Tech third semester students. Pigeonhole Principle. Basically, in 1834, German mathematician Peter Gustav Dirichlet stated a principle which we called a drawer principle. Now it is known as the pigeonhole principle. Pigeonhole principle states that if there are fewer pigeonholes than the total number of pigeons and each pigeon is put into the pigeonhole, then there must be at least one pigeonhole with more than one pigeon. If n pigeons are put into the m pigeonhole, where n is greater than m, there is a hole with more than one pigeons. We can also elaborate this principle if there are m pigeonholes and n pigeons are there and n is greater than m. If pigeons are more than the pigeonholes, then there must be at least one pigeonhole which has more than one pigeons. Yeah, there is at least one pigeonhole which has two or more than two pigeons. This is also elaborated like this: if there is n pigeonhole and n plus 1 pigeons are there, then there must be at least one pigeonhole which has more than one pigeons. Just for example, suppose a department contains 13 professors. Then two of the professors is treated as pigeons, were born in the same month, like pigeonhole. Just for example, we see like there is 13 professors, and two of them can born in the same month. It means n equal to 12. N equal to 12. This is a pigeonhole. This is a pigeonhole. Pigeonhole. And n plus 1. N plus 1 means 12 plus 1. That is 13. That is 13. 13 is the pigeons. So 13 is pigeons according to the simple pigeonhole principle. If there is n pigeonholes occupied by n plus 1 or more pigeons, then there must be at least one pigeonhole which has more than one pigeons. Here n equal to 12, yani in a year 12 months are there, so 12 pigeonholes are there. One more, yani n plus 1, that is 13 pigeons, yani ki 13 professors, in which two of them, more than one, can be kept into the one pigeonhole, yani ki two of them can born in the same month. So here 13 professors can, in which two of them can born in the same month. So this type of question is related to pigeonhole principle. Another example we see, find the minimum number of elements that one needs to take from the set S equal to 1, 2, 3 up to 9 to be sure that two of the numbers add up to 10. So minimum number of elements that one needs to grab from the set S equal to 1 to 9, so that two of them guarantees that two of them adding up give to the 10. So first of all, we have to find out pigeonholes. So pigeonholes, graph from the set S equal to 1 to 9, so that the sum of the two numbers add up to 10. So pigeonholes are 1, 9, 2, 8, 3, 7, 4, 6 and 5. So there are 5 pigeonholes. So 5 pigeonholes, thus any choice of 6 elements Yani there are 5 pigeonholes, so one more pigeons are required than the pigeonhole. So there is a 5 pigeonholes, so n plus 1, that is 6. 6, any choice of 6 elements, या pigeons, will guarantees 2 of the number add up to 10. We can also see, for example, 1, 2, 3, 4, 5. Suppose we are picking, we are grabbing 5 elements from the set S. So anyhow, it does not guarantees 2 of them, sum of the two of them is 10. So if we take a 6, so 6, so sum of them is 10, it guarantees. So in a worst case, it also guarantees, if you are picking a 6 elements from the set S, it will guarantees that the sum of the two numbers add up is coming 10. So that if 7 numbers from 1 to 12 are chosen, 2 of them will add up to 13. In this example, first of all, we have to make a pigeonhole. So 2 of them will add up to 13 from 1 to 12. So what will be the pigeonhole? Pigeonhole will be 13 add up to 13, that is 112, then 211, then 310, 49, 58 and 67. So 1, 2, 3, 4, 5, 6. So n equal to 6. 6 pigeonholes are there. So each of 7 numbers belongs to one of these 6 sets. Since there are 6 sets, the pigeonhole principle tells us that 2 of the numbers chosen belongs to the same set. The number add up to 13. It means there are 6 pigeonholes, in which one more, 6 plus 1, that is 7. So 7 numbers from 1 to 12 are chosen, in which 2 of them will add up to 13. For example, suppose we see 1, 2, 3, 4, 5, 6, 7, 7. So if we take a 7 and 6, it will guarantee the sum is 13. If you not pick this, then no 2 of these can guarantee the sum will be 13. Generalized pigeonhole principle. Generalized pigeonhole principle: if n pigeonholes are occupied by kn plus 1 or more pigeons, then where k is a positive integer. What it say? If n pigeonholes are occupied by kn plus 1 or more pigeons, where k is a positive integer, then at least one pigeonhole is occupied by k plus 1 or more pigeons. This is generalized pigeonhole principle. What it say? If n pigeonholes are occupied by kn plus 1 or more pigeons, where k is a positive integer, then there must be at least one pigeonhole which has k plus 1 or more pigeons. Another example we see, find the minimum number of students in a class to be sure that 3 of them are born in the same month. 3 of them are born in the same month. So here 3 k plus 1, this is a pigeon actually, k plus 1 equal to 3. So here k equal to 2 is a positive integer. Minimum number of students. So minimum number of, and n equal to 12. In a year 12 months are there. So pigeonholes are 12. Minimum number of students equal to kn plus 1. That is k equal to 2 into n equal to 12 plus 1, that is 25. So out of 25, 3 of them are born in the same month. In worst case, what happened? 1, 2, 3 up to 12, these are born in the January, February and so on, December. again 13, 14, 15 up to 24, again born in January, February and so on, January, February and December. And this, suppose this is a 25 students born in the Jan. So three of them can born in the same month. So find the minimum number of students in a class to be sure that three of them are born in the same month. So three of them, these students like 12, 12, 24 plus 1, that is 25. So 25 out of 25 students, it guarantees that three of them can born in the same month. So this is the application of generalized pigeonhole principle. Another example we see, find the minimum number n of the integers to be selected from s equal to 1 to 9, so that the sum of 2 of the n integer is even and the difference of 2 of n integer is 5. So minimum number n of the integers to be selected from the 1 to 9, so that the sum of the 2 of the n integer is even. So we know even plus even equal to even, and odd plus odd equal to also even. So first of all we have to make pigeonhole. So pigeonhole will be from the set S, pigeonhole equal to, take a odd number will be 1, 3, 5, 7 and 9, and even number will be even equal to, this is a odd, that is 2, 4, 6, 8. So two pigeonholes are there, one more pigeons, that is 3. So 3 will guarantees that the sum of 2 of the integer is even. So what we will do here, so take 3 numbers like 1, 2 and 3. So this will guarantees that the sum of the 2 is even, that is 1 plus 3 equal to 4. Suppose we take only 2, so this will not guarantees. So 2 and 3, this is not guaranteed, and take like 2, 3 and 4. So this again, this is sure the sum of the 2 is even. So here we have to take 3 integers from s equal to 1 to 9, will guarantees that the 2 of the integer is even. B, the difference of the 2 of n integer is 5. Again we have consider subsets like pigeonholes, the difference is 5. So we take from this, that is 1, 6, 2, 7, 3, 8, 4, 9 and 5. So 5 subsets are there and will be treated as a pigeonhole. Then 6 will guarantees one more pigeons. If n pigeonholes are there, then n plus 1 pigeons sure that 2 or more than 2 will occupy a same pigeonhole. It means 6 will guarantees that 2 integer will belong to one of the subset and their difference will be 5. Again another example we see, find the minimum number of students needed to guarantee that 5 of them belongs to the same class. So here class, this will be treated as a pigeonhole. So class is freshman, sophomore, junior and senior. So there are 4 pigeonholes, n equal to 4, 4 pigeonholes are there. 5 of them, so 5 of them means k plus 1 is given, k plus 1 equal to 5. Apply here generalized pigeonhole principle. What generalized pigeonhole principle says? It says if there is a n pigeonholes are occupied by kn plus 1 or more pigeons, then there must be at least one pigeonhole which has more than k plus 1 or more than k plus 1 pigeons. So here k plus 1 is given as a 5, then k equal to 4. Again total number of pigeons are kn plus 1. So, kn plus 1, that is 4 into n equal to 4 plus 1, that is 17. So, 17 students, 17 pigeons needed to guarantee that 5 of them belongs to the same class, like freshman, sophomore, junior and senior. So, this is the use of pigeonhole principle and generalized pigeonhole principle. Suppose that there are 10 pigeons. Suppose there are 10 pigeons and there are 9 pigeonholes. In the evening, each pigeon will pick one of the pigeonholes to stay. In one of the pigeonholes, there will be at least 2 pigeons. It means out of 10 pigeons and 9 pigeonholes are there, there must be at least 1 pigeonholes which has more than 1 pigeons, at least 2 pigeons. There will be at least 1 pigeonhole which has at least 2 pigeons. If k is a positive integer and k plus 1 objects are placed into the k boxes, then there at least one of the boxes will contains 2 or more objects. Example, if a bag contains 10 red marbles, 10 white marbles and 10 blue marbles, what is the minimum number of the marbles we have to choose randomly from the bag to ensure that we get 4 marbles of the same colors? So, here we see 10 marbles of red, 10 marbles of white and 10 marbles of blue. So, n equal to 3. 3 pigeonholes are there. Ensure that we get 4 marbles of the same color, 4 marbles, yani here k plus 1 is given as a 4. So, k equal to coming 3. Minimum number of marbles is kn plus 1, that is 3 into 3 plus 1, that is 10. So, 10 marbles guarantees that 4 marbles of the same color. So, suppose we see red, white and blue. Again red, white and blue, red, white and blue, and this is a red. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 marbles, out of 10 marbles, 4 marbles of the same colors. This will give a surety. Minimum number of the marble would be 10. Another example we see, in a computer science department, a student club can be formed with either 10 members from first year or 10 members from the second year, or 6 from the third year, or 4 from the final year. What is the minimum number of students we have to choose randomly from the department to ensure that a student club is formed? So, we can directly apply for the above formula. Here Q1 equal to 10, Q2 8, Q3 6 and Q4 equal to 4, n equal to pigeonholes are 4. So, therefore, the minimum number of students required to ensure department club to be formed is 10 plus 8 plus 6 plus 4 minus 4 plus 1, that is 25. So, here what we see here? We see here use of pigeonhole principle in day-to-day life. So, again we are going to summarize a simple pigeonhole principle. It states that if there is n pigeonholes and n plus 1 or more pigeons are there, n plus 1 pigeons are there, then there must be at least one pigeonhole which has more than 1 pigeons. This is, for example, out of 49 students, 5 students can bond in the same month. Generalized, this is because of generalized pigeonhole principle. It states that if there are n pigeonholes and kn plus 1 or more pigeons are there, then there must be at least one pigeonhole which is occupied by k plus 1 or more pigeons. So, here we see out of 49 students, 5 of them can bond in the same month. So, how generalized pigeonhole principle works? So, out of 49 students, 5 of them can bond in the same month. So, in this example, pigeonhole is 12 because in a year 12 months are there and students can bond in any month. So, there is a 12 pigeonholes and 5 of them can bond in the same month. So, this is the value of k plus 1 equal to 5. So, here k equal to 4. Total number of pigeons, the total number of students, minimum number of students required is kn plus 1. So, kn plus 1, that is 4 into 12 plus 1, that is 49. So, 49 students. So, out of 49 students, 5 of them can bond in the same month. It means if n pigeonholes are occupied by kn plus 1 is 49 or more pigeons, then there must be at least one pigeonhole which has k plus 1 or more pigeons. It means k plus 1 is 5. So, out of 49 students, 5 of them can bond in the same month. Thank you.